Welcome to this AQA GCSE Geography warm-up video. It's the third in a series of videos designed to guide you through last-minute preparations for your GCSE Geography exams. This one looks at Paper 1 Unit C, which is Physical Landscapes of the UK. The paper assesses all of your physical geography topics, the challenge of natural hazards and the living world, which we've covered in the two previous videos, and the UK physical landscapes, which will be supported by this video. Remember, there is some optionality in this paper. Within Unit 1B, the living world, you will have studied either hot deserts or cold environments, so you need to make sure that you pick the correct one when you're answering questions. And within Unit 1C, physical landscapes, you will have studied 2 out of rivers, coasts and glaciated landscapes. So again, look out for the correct sections and don't answer all 3 within Unit 1C. So like we've said, in Unit 1C you have the choice of coasts, rivers and glaciated landforms. You have to study 2 of these. Across the country, the most popular options are coasts and rivers by a long way, with the majority of centres studying these. So the video is just going to focus on those 2 units. On the screen is a taste of what you will have covered in each of the units. Pause the video for a moment if you need to. So we're going to start off by looking at coastal landforms. So if you've studied the coastal landform option, you need to understand the physical processes that shape the coast. These are weathering, mass movement, erosion, transportation, so for example longshore drift, and deposition. For erosion, weathering and mass movement, you should be able to refer to specific examples of these processes. You need to understand how those specific processes create distinctive landforms through erosion and deposition. And you need to know how the landforms listed on the screen are formed along with their specific processes. For example, which types of erosion are taking place. You also need to know the different types of hard and soft engineering strategies in place, and you should be able to evaluate their effectiveness. Finally, you should have studied these in the context of one area of coastline, which you need to be able to refer to in some of your answers. So we're going to start off with a bit of knowledge retrieval on erosional processes. It's really important that you know the different ones because they will come up in both coasts and rivers. You've got 60 seconds to match up the key terms with their definitions. Good luck. Okay, let's see how we got on. So these are the correct answers. If you got all 5 right, then well done. So erosion is the wearing away of the cliff face or riverbank or bed by the flow of water. Hydraulic action, which is also sometimes known as hydraulic power, is the force of the water hitting the cliff face or the riverbank and squeezing air into cracks in the rock and weakening them from the inside. Abrasion is the force of the sediment and rocks in the water scratching and scraping away at the cliff face or the river bank or bed. Attrition is a process of rocks hitting each other and breaking into smaller rocks as they're being transported along. And solution is a chemical reaction between the sea or river water and the minerals in the rock in the cliff face or the river bank or bed, which causes the rocks to dissolve. So if you got all 5 correct, well done. And remember, you do need to refer to specific processes of erosion in questions about landform formation. It's not just okay to write these have eroded. You need to talk about which ones in particular have been used. And our first 6 marker is explain how weathering processes help shape the coastline. So you need to think about the different types of weathering and how these weaken the rock and the effects of mass movement on the coastline as well. So if you want to attempt this question first, pause the video, spend 6, 7, 8 minutes having a go at this question yourself, and then unpause the video and we will talk you through a model answer. So if you want to do that, pause the video now. Okay, we have a model answer here. So I'm going to read through. While I'm reading through, think about why it would achieve all 6 marks. So we're going to start off with weathering is a breakdown of rocks in situ and it plays a key role in shaping the coastline. So you don't particularly need this little introduction, but it does show the examiner you know what weathering is. Freeze-thaw weathering causes water to collect in cracks and cliffs, which then freezes at night and expands, forcing the cracks to become bigger. When the ice thaws, water then seeps deeper into the rock, which will then freeze again once temperatures plummet. Repeated cycles of freezing and thawing causes fragments of rock to fall off and collect at the base of cliffs. Chemical weathering also damages cliffs. For example, acid rain reacts with alkaline rocks such as chalk and limestone and causes the rock to dissolve slowly. This weakening of the rock can lead to mass movements such as landslides, where huge chunks of the cliff can break away and collapse into the sea. Much of this material will be carried away by waves and deposited further along the coastline. So why would it achieve all of the marks available? Well, 6 markers need 2 well-developed paragraphs. We've written about freeze, thaw and chemical weathering, and we've talked about how the processes work. So for example, we've talked about the cycle of freezing and thawing and what this does over time, and at the end of each paragraph we've said what it actually does to the coastline, so it ends up with rockfalls and landslides. In this answer, you could also talk about biological weathering, so you could talk about the problem with animals burrowing, you could talk about tree roots and the issues that causes. You could talk about onion skin weathering, so the idea of heat, that sort of exfoliation happening there. You could even talk about salt weathering. It is an explain question, so it's one that tests AO1 and AO2, so your knowledge and understanding. So there is no need for a conclusion for this question. In this section of paper 1, you will be asked about the formation of certain landforms. So it's essential that you know your landforms in terms of the sequence, which is something that generally students do quite well, but also the specific processes involved, which is something that year on year the examiners say is not done very well. On the screen, we've got 6 statements about how stumps form. So each of those statements is part of that process. They're just in the wrong order. You need to pause the video to try and put them into the correct sequence. Once you're happy with your sequence, if you can press play, and we will check whether you have got them in the right order or not. Okay, let's see how you got on, and let's have a look at the correct sequence. So we start off with a headland has a crack in it. Abrasion and hydraulic action means that the crack gets bigger and it becomes a cave. Wave erosion deepens a cave and it cuts through the headland and forms an arch. The roof of the arch is weathered and collapses as there is nothing to support its weight. A stack is left behind, and over time the stack is eroded and it forms a stump. So hopefully you've noticed that as well as getting the sequence correct and referring to the different landforms, the answer also includes specific processes of erosion that are important here: abrasion and hydraulic action. Now the sequence is a reasonable answer for a 4-mark question about stump formation. In order to get a full mark, you need a little bit more. So you could talk about the process of stack to stump. So what's actually happening there that makes that stack collapse and left to form a stump? Because you're right, there is erosion involved, but also you've got some weathering processes that you could talk about there. So it is quite a basic answer. If it was a 6-marker, it would obviously need a lot more detail. So you need to talk at length about the different processes and what they're doing, talk about the weathering processes. You would need not just to mention them, but you'd actually need to explain what they are. So if we're thinking about hydraulic action, then the reason that crack is getting bigger in the first place is because the force of the water is going into those rocks and it's causing the rocks to weaken. If you're going to mention abrasion in a 6 marker, you're going to need to talk about what abrasion does, so the whole idea of the scraping away. So we've got an answer here where we've got a sequence. We've talked a little bit about some of those key processes, but in terms of a 6 marker, you are going to need to talk about them in a lot more detail and you're going to need to explain them. Right, let's have a go at another question. So we've got another 4 marker here. Explain how sand dunes develop. We've got to this time think about the role of wind, any obstacles, and how vegetation helps to stabilise the dunes. Again, you might want to pause the video, spend 5 minutes attempting this question before I talk you through a model answer. So if you want to do that, pause the video now. Okay, let's have a look. So just remind ourselves of the question again. It was explain how sand dunes develop. Let's read through. We'll think about why it would achieve all 4 marks, because this time it would. Sand dunes form where onshore wind blows sand inland and deposits around obstacles on the beach, such as pieces of wood or rocks. These will develop and over time will become stabilised by vegetation such as marram grass. Marram grass has long roots to find water below the sand. These long roots bind the soil together and stabilise the dunes. Over time, decomposing vegetation will add organic matter back into the soil, increasing fertility and enabling greater biodiversity. So why did it get all 4 marks? Well, 4 markers need 2 well elaborated points. And in this answer, there is good elaboration about how the dunes are formed by wind, but also about the role of marram grass. You'll also notice there's quite a lot of subject specific vocabulary in here as well. We're talking about decomposing vegetation. We've referred to organic matter. We've talked about increasing fertility. We've mentioned enabling greater biodiversity. So all of those things there are helping you show your examiner that you've got really good understanding of processes and how things work. Right, we're going to move on to a 6 marker. So this time we're going to have a look at this question here. Discuss the advantages and disadvantages of hard engineering at the coast. Let's just quickly remind ourselves what hard engineering is. It's the idea of using structures to either stop flooding or slow down the process of erosion. It is quite an expensive way of protecting the coast, but there are obviously lots of other advantages and disadvantages to consider as well. So this time we're going to gather some ideas using the on-balance activity that we have seen in previous videos. So we've got our question at the top. Give 2 advantages of hard engineering at the coast. And this is a really good activity because in this section of the paper, you're often asked to consider the pros and cons of different coastal management strategies. And we're going to have a think about those hard engineering strategies through this on-balance activity. So have a think about the advantages of using methods such as sea walls, groins and rock armour. And remember, you can actually compare it to soft engineering strategies in your answer if you wish. So I'm going to give you a moment, pause the video briefly and have a little bit of a think about what you might put down as your advantages. When you're ready, press play and we'll go through potential answers that you could have come up with. Okay, let's have a look. So in terms of our advantages, if we're thinking about the pros of a hard engineering the coast, the fact is that things like seawall provide a barrier to flooding, therefore they keep homes and businesses safe. And because hard engineering involves building structures that are long lasting, people will feel more secure and that they are less at risk. But you could also say that groins build up the beach by holding sand in place, which slows down erosion and the water has further to travel as the beach is bigger and steeper. But the build-up of sand probably improves the look of the beach also, which increases its tourist potential, as tourists love wide sandy beaches. And of course, if you've got more tourists coming in, there's going to be more income coming into the local area. Okay, let's move on to the disadvantages. There are lots of drawbacks to hard engineering strategies. So how many can you think of? Again, pause the video if you need to. Think about the disadvantages of things like sea walls and groins and rock armour. Okay, let's have a look. There are lots of disadvantages to hard engineering at the coastline. It damages coastal habitats and also affects transportation processes, which can increase erosion elsewhere. For example, groins trap beach material, which means areas further along the coastline without coastal defences are starved of sediment, so therefore their erosion rates increase. One of the reasons that coastal defences are not everywhere along the coast is because they are so expensive. But another argument that often comes up is that people think sea defences are unattractive and they can restrict access to the beach. So remember, when you're asked to evaluate coastal management strategies, you need to present both sides, backed up with examples. And if you can present some evidence of issues along a specific stretch of coastline that you've studied, then even better. And in fact, some questions will specify that. So obviously, if you are asked to do that, you need to make sure you do. You can also compare hard engineering methods to soft engineering in your answer. For example, you can talk about the impact of coastal habitats, whereas soft engineering methods like beach nourishment is working with nature, however, is not long lasting. So let's quickly remind ourselves of the question that we started off with at the beginning of the On Balance activity. Discuss the advantages and disadvantages of hard engineering at the coast. So you might want to have a go at this question. If you want to have a go at the question, pause the video, spend 6 or so minutes coming up with your own answer, and then we're going to go through a model answer and think about why it gets all 6. Once you're ready, press play and we will go through the model answer. Let's have a look at this answer and think about why it gets all 6 marks. There are several advantages to using hard engineering strategies at the coast. Seaside towns tend to have expensive housing and lots of businesses, so these need defending effectively. Although a seawall is expensive, it acts as a barrier to stop flooding, and the fact it's made out of concrete means it will last a long time. Therefore, residents will feel safer. On the other hand, many people feel that seawalls are very unattractive and spoil the views as well as affecting access to the beach. Groins trap sediment, enabling the beach to build up and offer protection against erosion, as well as increasing tourist potential with wide sandy beaches. However, because sea defences are expensive, they are not everywhere, and areas further along the coast without groins will have their beaches starved of sediment, causing more erosion. Overall, although there are some concerns with hard engineering, these methods are long-lasting, so will protect people and property more effectively than soft engineering methods. So I've chosen to focus my paragraphs on 2 different methods of hard engineering, and within each paragraph I've explained why the method is effective at either stopping flooding or erosion, but I also offer a counter-argument for each one too. To make this even better, you could use specific examples of coastal defence schemes that you have studied. Let's move on to rivers. So if you've studied the river landforms option, you need to understand the fluvial processes that shape rivers. These are erosion, transportation and deposition, and you need to know how these change along the long profile, as well as knowing how the river valley changes along the long profile. You need to understand how geology and physical processes create distinctive landforms through erosion and deposition, and you need to know how the landforms listed on the screen are formed along with their specific processes. For example, which types of erosion are taking place. You should also be able to contextualise some of these landforms along with a specific river. You need to understand how different physical and human factors increase the flood risk, and you need to know the different types of hard engineering and soft engineering strategies in place. You should be able to evaluate their effectiveness. In this section of paper 1, you will be asked about the formation of certain landforms. So it's essential that you know your landforms in terms of sequence, but also the specific processes involved, like we talked about for coasts. This time we're going to use a chains of analysis activity to form the perfect paragraph explaining how waterfalls form over time. On the screen we have 5 statements that form an explanation of waterfall formation. They're just in the wrong order. So you need to pause the video and try to put them into the correct sequence. Pause the video now, and when you're done, you can press play to check your answers. Okay, let's check the correct order. Let's have a look at the correct order. A river flows over resistant hard rock, then less resistant soft rock. A waterfall begins to form as a soft rock is eroded at a faster rate by hydraulic abrasion and solution. Undercutting creates an overhang of hard rock and a plunge pool develops beneath the waterfall. The overhang collapses and attrition acts on rocks in the plunge pool, making them smaller and rounded. The waterfall then retreats upstream, leaving a gorge downstream. So what makes it a good answer? Well, we have the idea of different rock types, although we haven't specified them. And again, you might want to specify them in, if you're talking about a waterfall that you could talk about the rock types involved there. We've talked about the fact that some rocks are more resistant than others. We have the sequence in the correct order, and we've referred to the different types of erosion throughout. It's worth remembering that if you struggle with the sequencing and explanation of landforms, you can actually draw the diagram instead, but you've got to make sure that it is annotated. It's unlikely to give you all marks unless your annotations are spectacular, but it's certainly better than getting none. So this is fine for a 4 marker. If we were looking at it for a 6 marker, then once again, you would have to talk about those processes in much more detail. So how is hydraulic action causing the erosion here? What's abrasion actually doing at the plunge pool? Talk about solution, don't just mention it, talk about what it's actually doing. So this time, same activity, different question. Explain how an Oxbow lake forms over time. So again, it's a good one to test as it also tests meander formation. But in a question about meander formation, you'd obviously need to think about what was happening on the inside and the outside of those meander bends in detail, along with the specific erosional processes, which is not required here. Like before, we've got 5 statements that form the explanation of an Oxbow lake. They're just in the wrong order. You've got to pause the video and try to put them into the correct sequence. And once you're happy with your order, then press play and we'll check whether you have got them correct or not. Okay, let's see how you did. So did you get the sequence correct? Well done if you did. A meander neck is eroded over many years until it becomes very narrow and then a flood occurs. Extra erosive power enables water from the main channel to break through the meander neck. Flooding subsides, but most water in the river now follows a new, shorter channel. Deposition occurs at the side of the new channel, reducing flow around the old meander, and over time further deposition cuts off the old meander completely and it creates an Oxbow lake. So in this case, a paragraph would score all 4 marks because it is correctly sequenced and it shows a good understanding of the different processes operating here, and in particular the transition from erosion being the key process to deposition becoming more important. Now the big mistake that happens here is that students often just talk about meander formation and they don't really talk about Oxbow lake. So they might just mention it in the very last sentence once they've described the meander bends and the process of erosion and deposition happening there. They might just say, so over time this leaves an Oxbow lake that gets cut off. Now be really careful here because obviously this question is all about Oxbow lake formation, so just having it at the end tacked on isn't good enough. But if you spend a lot of time talking about meander bends, then that's not relevant, so you're not going to get the marks, even though you might be showing some excellent geography. Right, we're going to have a go at connection spinner. So it's really important to know about your fluvial processes and the landforms within the topic, but we also need to think about flooding and in particular the causes and impact, and you will have studied a case study on this. So in this activity, the connection spinner, we're going to test how well you can apply your knowledge. You're going to see 6 human and physical factors that increase the risk of flooding. We're going to spin the spinner and whatever it lands on, we need to be able to explain how that factor increases the risk of flooding. So let's have a look at our first one. So let's see where that spinner is going to land. And it's hidden one of our factors. So in a minute you will see relief in that missing one at the top. Okay, so it's landed on deforestation. So how does deforestation increase the risk of flooding? Let's have a look. Well, it increases the risk of flooding as there are less roots to absorb the water and less leaf coverage to intercept rainfall and stop it reaching the ground in the first place. So that is a factor that increases the risk of flooding. Right, let's go again and see what it's going to land on. and for some reason we have nothing showing up at the moment, but let's have a look at what they will be. There we are. I'm not really sure what's happened there, but it's landed on urbanisation despite the fact they were all invisible for some unknown reason. So we think about urbanisation, it's the idea of more and more people living in towns and cities, and if towns and cities are growing, then we are covering more and more of the landscape in tarmac or concrete, and these are both impermeable, which means that they do not allow water to absorb. And if water is not absorbing into the land, then it does mean that surface runoff is going to increase. And surface runoff is the idea of the water just going back over the surface. It's often known as overland flow, trying to make its way back into rivers. And obviously we don't want that happening. We want it to absorb into the ground where it's going to not lead to huge flood events. So let's have a look at some of the other factors while we're here. We're not going to spin it again because obviously there is an issue with my spinner. We've got prolonged rainfall, so prolonged heavy rainfall can lead to flash flooding as the river channel gets completely overwhelmed, but it also means that the ground becomes completely saturated and it's unable to absorb any more water, and we often see this in the winter. So you see fields that are completely, that almost look like lakes because they are so soggy and saturated that they just can't get any more water into the soil. Geology obviously plays a really big role here. Impermeable rocks such as clay or slate stop infiltration from occurring. So infiltration is the idea of water soaking into the soil. So instead that water flows over land to get back to river channels. And relief is similar. So in upland areas, steep slopes make it much harder for infiltration to occur. So the water runs down those steep slopes instead. Right, let's move on to another 6 marker. We are going to gather ideas using the on balance activity like we did for coasts, and our question this time is: the benefits of hard engineering strategies to minimise the risk of flooding outweigh the costs. To what extent do you agree with this statement? So we know how this activity works because we saw it in the first part of the video, and we've talked about why the on balance activity is quite a good one. And in this section of the paper, so the section with the questions on rivers, you're often asked to consider the pros and cons of different management strategies for rivers. So think about hard engineering strategies such as dams, channel straightening, flood embankments, etc. And remember, you can compare them to soft engineering strategies if you wish. So pause the video for a few moments, see if you can come up with some advantages of hard engineering strategies that reduce the risk of river flooding. When you are happy with those, then press play and we'll have a look at what you could come up with. Okay, let's have a look. So one of the main arguments in favour of hard engineering strategies along rivers is that they provide effective protection and properties are far less likely to flood, so the economic cost is far lower, both in terms of costs of repairs, but also in terms of businesses closing temporarily and losing their income. Some methods of protection also offer recreational tourist value. For example, building dams creates a reservoir behind the dams, and these reservoirs are often used for water sports and other activities such as cycling and hiking. Therefore, they provide an amenity value for local people and tourists, which will generate money for the local economy through the multiplier effect. So, for example, a water sports activity centre will require qualified staff, but visitors will also want somewhere where they can get refreshments. So a cafe will open up, creating jobs. If it's quite popular, they'll be able to generate lots of money through a car park where people might pay £5 to park all day. That's going to bring in hundreds of pounds every day to the local economy. Okay, let's move on to disadvantages. There are lots of drawbacks of hard engineering strategies. How many can you think of? So again, if you pause the video for a few moments, have a think about some of these problems caused by embankments, perhaps something like dredging. Think about the problems caused by dams. Once you've got a couple written down, then press play and we'll have a look at what you could have come up with. Okay, let's have a look. So one of the biggest issues with hard engineering strategies is that they are very expensive to install and maintain, so there needs to be evidence that the land being protected from flooding is actually economically valuable. Installing defences like embankments causes environmental damage, and they can spoil the look of an area as they are so unnatural, but they also disrupt habitats. Other strategies that disrupt habitats are dredging, which damages the riverbed, and finally large-scale projects such as dams create problems further downstream. For example, the dam will block the flow of the water, meaning that less of that water reaches downstream, which may impact fishing and farming. But the dam also blocking the water will cause a reservoir area to form behind the dam, which we've already said is an advantage in terms of being an amenity value, but suddenly you've got a water level that's much higher than the original river, which is going to be quite a lot colder. This then means that those marine species that were in that river are now going to really struggle to adapt to the changing conditions. So remember, when you're asked to evaluate river management strategies, you need to present both sides, and if you can, back them up with examples and present some evidence of issues along a specific river, that's going to be even better. You can also compare hard engineering methods to soft engineering methods in your answer. So for example, you can talk about the impact on river habitats between the two, but you can also talk about things like how soft engineering methods such as afforestation would take a long time to be effective in comparison to those hard engineering strategies. Let's just remind ourselves of the 6-marker question that we started off with. The benefits of hard engineering strategies to minimise the risk of flooding outweighs the costs. To what extent do you agree with this statement? If you want to have a go at this question yourself, pause the video, give yourself maybe 6, 7, 8 minutes to have a go at the question. Once you have done that, press play and we will talk you through a model answer that gets all 6 marks. So let's have a look at that model answer. Floods occur every year across the UK, causing huge amounts of damage to property, making people temporarily homeless and closing businesses. By installing hard engineering methods such as flood embankments, the capacity of the river increases, therefore flooding is less likely. People may argue that these are unattractive to look at, but as they save millions of pounds in repairs and insurance payouts, they also reduce the number of people who lose their homes. Another hard engineering strategy is building dams which control the flow of water so less water reaches downstream, stopping flooding from occurring. However, land behind the dam is flooded, creating a reservoir, meaning that some people could be displaced. Dams are incredibly expensive to construct, but the reservoir created can provide a water supply to homes and businesses, as well as creating a leisure amenity which would provide jobs. In conclusion, I strongly agree that hard engineering is the best way to minimise the risk of flooding, and although there are costs, these are outweighed by the social and economic benefits. So I've chosen to focus my paragraphs on 2 different methods of hard engineering, and within each paragraph I've explained why the method is effective at stopping flooding, but I also offer an alternative viewpoint for each one and a response to that. The reason I've done this is because I've said I strongly agree, so when I present a counter argument, I want to be able to almost dismiss it. To make the answer even better, you could use specific examples of river management schemes that you have studied. The other way to approach this question would be that you would have perhaps one paragraph focusing on the pros and cons of your hard engineering strategies, and you might want your second one to be about soft engineering strategies as an alternative, and then you could talk about in your conclusion which one you thought was better there. So we have revised our key processes, landform formation, and we've also evaluated management strategies for both coasts and rivers. Hopefully this video will help you go into your paper 1 exam feeling more confident, particularly with those longer answer questions. So wishing you heaps of luck.